Okay, welcome back. We continue for the Gauss Seidel. Okay, we continue for the Gauss Seidel. It will take a few minutes only just to teach you the Gauss Seidel. The Gauss Seidel is one of the numerical method to solve the problem, linear system problem. Let me introduce to you one simple logics of the Gauss Seidel. Okay, Gauss Seidel. There are many methods. Again, I repeat to you, there are many methods. What you are learning is a very limited methods basically. Okay, for the Gauss Seidel method. Gauss Seidel method. Okay, let's say the equation is will be same. Okay, equation will be a linear system. 5x3 equals to 1, x1 5x2 3x3 28, 3x1 7x2 plus 13x3 equals to 7 6, and they will give you, okay, this is since a numerical method, they should give you initial guessing. Okay, let's say I give you initial guess. This is okay, without initial guess you cannot move on. Okay, can you guess by yourself? Cannot. Okay, the question they should give you, okay, the what you call the examiners should give you the initial guess. But in actual cases, actual scenario, you can guess by yourself. Okay, you are allowed to do that. But in our case, no. But you, let's say they have given, this is the initial guess that you can, the initial guess. Again, I remind you, please, you do not guess by yourself. You cannot guess yourself. Okay, in order to solve the Gauss Seidel, okay, you need to go to the site. Okay, you need to go to the site. You can see this. Okay, the diagonal. First, you look at the diagonal here. Okay, and this diagonal will remind you something. The diagonal of this actually is, let's say I call it as a A11. It's a diagonal, right? If I take it a negative or positive, doesn't matter. It should be modulus of that should be added. When we added that together, it should be greater. Why? Later I'll let you know. For example, in this case it's a 12. Is a greater compared to I3 3 and plus negative 5. Negative 5 is still 5. You add up. Okay, so since we are using modulus, it's true. We need to make sure 2 2. This is very important. This is very important. Normally people are not care about that. Okay, if you don't care, then it's a problem. Why? I'll let you know. Give me 1 minute. We need to take a modulus of this and check again here at this part. Okay, whether we are taking care of the diagonal. Yes, this is less than. Okay, now we need to check. Okay, you see, Gauss Seidel can work very effectively for this scenario only. That's it's easy method, but it works only for this scenario only. Effectively I'm saying. Okay, 3 plus 7. Okay, confined. Okay, it's all complied these rules. Okay, if the compliance here, okay, this is what I wanted to say, is when you take and I, okay, 1 and j, okay, you plus 1 plus something not equals to I, and you take a ij, okay, you add up for at least one I. Okay, at least for one I. Diagonally must be dominant. Diagonally dominant. dominant. If it is a diagonally dominant, the word diagonally dominant, then the solution or the initial gas will converge. Converge means you possible to get answer. Otherwise, no, it's not easy to converge. It never converge. Okay, you need to go on and on and on. Okay, what is the rules? I use a simple rules to handle this problem. Okay, now in order to, this is very important. This rules is very important. Okay, if not comply, you cannot converge. It never converge. Okay, you may say, sir, is there any other way? Yes, you need to find other way to, if this not comply, you need to use some other method. Okay, you need to use some other method to solve. Okay, now I think the pen finish these things. Okay, when we start, okay, how to handle this? Okay, the model. Okay, sorry, earlier the camera stopped by itself. Okay, now come back to the other idea. Okay, for the x1, let's say we give a x1, or later I'll change it to the k1, k2 and something like that. Okay, we just pick x1 and you bring it the rest. Okay, you bring it this rest to this side, the other side. Okay, this is the easiest method. You can see 12. Okay, 1 minus 3x2 5x3. Okay, same thing. Okay, the same thing that you can do here is this. Okay, in this particular case, you can start with the x2. For example, you want to choose x2, you bring it rest of the things, okay, the variables to the other side. Okay, when you start doing this, okay, you will get a x2 1 over 5 28 x1 3x3. Okay, this is a first round. Later I'll choosing that as a k1 and k2 and k3. Okay, for the x3, similarly you need to do the same thing. 3x1 7x2, that's what you need to do it. Okay, use the latest value of this. That's a very important message that I would like to give. You're going to use x1, x2, x3, this value 1 0 1. The best is a table. I will show you how to use table, how to create table. Then note, okay, the message here I put 2 star 3 star whatever. Use the latest value of xi. You must use the latest. Okay, the latest to solve the problem. Okay, now I'll choose the first one. You can see how am I doing the portion of this. Okay, we need to use the latest, right? Okay, now I use the round 1. Round 1, this is the round 0. I call it because I'm using the initial value. Therefore, I put here is round 0 because I'm choosing the. You can call it round 1 or round 0 also, but I just choose this as a round 0. Okay, because we didn't get it yet. This is the guess is already there. We are going to guess. Okay, therefore we need to use equals to 1 over 12. Okay, 1 over 12 1 3. We just choose x. Okay, some of you may say, sir, can I organize in a different way? Up to you. Whatever. Is it I need to start with x1? No, not necessary. But stick to the convention again. 0. Okay, 5. 0.5. Okay, x2. Okay, this is a iteration, cycle, cycle. This one is a cycle, This is the first cycle we are doing, 0 cycle, because we are just using the existing one. Okay, now we found the new value for the x1 ready, 0.5, Okay, 5, 28, 0.5, 0.53, we get a 4.9. Okay, similarly, x3, 1 over 13, 1 over 13, 76, 3, the rules is already started. If you notice the value, is it already I substitute or not? The rules is use the latest value of xi, right? I forgot to let you know. Okay, you see, first when I start with the x1, I calculate the 0.5. When I come back to when I start immediately to the x2, okay, I should use x3 is no other value. What is the latest value that I have? 1. What about the x1? x1 is already new. Okay, I got a new value here, 0.5. I need to place here. This is very important. This one is very important. I substitute the new value here. Same here. Okay, see, for the x1 you need to use the latest value, and x2 you need to use the latest value. No other option for you. Okay, you cannot use 7, 4.9. Okay, many students never follow these rules. Therefore, they think okay, I need to substitute 0, 1, 0, 1, then only I start. No, immediately the mission will begin. Okay, you see, you are picking and you are doing this, and you are choosing the value of this. Your mission begin immediately. Okay, you need to substitute the latest value and you just proceed. You miss this part this way, then the whole calculation will be wrong. Okay, the calculation will be wrong. Okay, okay, I will continue for the okay, we continue for the table. The table, in order to create table, there is a standard way to create the table. The table creation works like this. Okay, the table creation works like this. Okay. Say okay. Okay, you create a table. Okay, you can add on for the error as well. Okay, I will just show you how to add k. For example, here you choose k. K means here iteration. x1k, x2k. Can you follow? X3k, and this is the error, to report the error. Okay, now you see the initial guessing. I just create the table very fast. One, two, three, four, five, six. Okay. Okay, my initial guess will go here. Okay, my initial guess will go here as a 0. Okay, it won't be calculated in the calculations actually. Okay, it's a accepted kind of value. Okay, number 1, when I started with the number 1, just now we calculated 0.5, right? For the x2 we calculated 4.9. Then immediately this one is a 0.923, right? Same. Then we need to pick the latest again. I remind you, please pick the latest value. Many of them they forgot they will start choosing these three. No, we need to choose, calculate. The first one is already 0.5. The second one, you need to choose the latest for the value. Okay, let's say in this particular case 0.14679. What you're supposed to do, you need to choose this latest value to calculate the x2. Okay, then only you will get a 37153, 38118, and let's say this is the solution lah. Okay, just we proceed first. I wanted to show you some value. Okay, how many value to go? Normally we keep to 4 or 5. Okay, we encourage for you to go to up to 5. 31644, 39704. Okay, 4 or 5, huh? Okay, I just let you know. 94675, 30281. Okay, how do we know it's actually converging? Okay, how do we know it's actually converging? That's what I wanted to show you. Okay, is it actually it could be a 9 to converge. Is it converging? Not yet. 3 4, but the things is converge here. 004. Okay, number one more. Okay, one more stage to see the converging. 099, you see, two value is already start converging. 9 19. The system will ask you over here. You can see 1 2 3. Is it 2 2 2 2 already converge? This one no, same, no problem. But you can see decimal to 2. This one decimal to 2 also. What about this? This one is decimal to 4. Decimal to 4 converged. That means this is nearly converged. The answer is will be something similar. When you calculate this value, okay, let's say you are getting this kind of solutions, then you can see the converging method. Okay, you can report the E for every one of these changes. Okay, you may say, what is this? What is the error here? The error, you can keep it as for the x1, ex1, 1, e2, you can do for alt. Okay, I leave it to you. Okay, but normally it's not encouraged lah. Computer system will do it that. Okay, you can do for the e2, e3. Okay, what you need to place here? Okay, you see the difference here, right? You can see the difference here, the error. Okay, what you need to do? You need to use the error in order to find out the error here. You need to keep on doing this. Okay, you need to use what we call error here, xi, the new, cannot see, the new minus with the xi old. New minus with the old, divide with the xi new. Okay, times with the 100, you will get certain percentage. Okay, you can write the percentage here. This much percentage, the error is there. Okay, over here you can see it's a 0. That means the error is a 0. When you come back to here, when you report this here, definitely the error is a 0 for this one. Okay, that means decimal is already complied for the 4 decimals, 4 decimals. Therefore, you will be given the question like the decimals, how many percentage? Sometimes they will say 5%, less than 5%. If you reach, you stop. You stop your iteration. Okay, this is how you need to stop. Otherwise, you may say, how do I stop the iteration? That means the cycles. The only cycles, the way one of the things is comply here. One of the things, maybe x1, x2, x3 comply for this. For example, the question may say, okay, if it is reached 5%, okay, one of the things comply 5%, okay, you just stop. When you calculate, yes, if some of here is stop, one of the things is complied to the 5%, okay, you just stop. you just report this value. Okay, in this case it's already reached to 0%, you know. This one is reached to the 0% already. Can you see that? This minus this. This is a new again. This is a new. This is a old. This is a new. This is a old. Divide with the new. When you do that, you will get 0. Okay, you will get 0. Okay, therefore now absolute relative error, we call it this as a absolute relative error. We need to use absolute relative error to find out. Sometimes they may use again 4 decimals. They will say follow up to 4 decimals. Okay, if you happen to see 4 decimals here, you can stop. You can stop. Okay, it's repeat. Same. 4 decimals ready. 1, 2, 3, 4. Stop. Okay, there will be some stopping criteria must be given. If they don't give you the stopping criteria, you won't be able to these things. Once you get this as a solution, this is your answer. This is your answer for the x1. Let's say in this particular case, if you stop here, okay, because of this, there are the stopping criteria again. The stopping, okay, okay, that means there's termination. Maybe I just say termination criteria. Termination criteria. Okay, they may use percentage. Okay, they may use 1. They may use a percentage. How many percentage? Okay, percentage. They may use decimals. They may use decimals to say, okay, you follow these decimals, you must stop. Okay, basically, but other than this, very rare. Other than this, they never ask you anything more than that. But okay, what is the solutions? What is the solution? Okay, the solution for x1, x2, x3 is this. You just pick this one as a solution. This is your solution. 9999. But those are little bit smart, but don't change anything your value here. Okay, if you get this is the solution for what? To solve what? Okay, to solve the problem called, okay, this is your solutions, right? Okay, when you get a this is as your solution, this the solution for this equation. Okay, this equation, the 12 x1 plus 3 x2 minus 5 x3 equals to 1, x1 5 x2 plus 3 x3 2 8, and 3 x1 7 x2 13 x3 76. Okay, the solution for this is this. Okay, okay, some of them they I know some last year some student asked, okay, where is the solution, sir? Okay, that is a solution. You just choose the last one as your solution. Okay, wherever you stop for the termination, that is the answer for the solution. Okay, okay, we have done the Gauss Seidel. Okay, remember, you must remember only one message that I stressed to you. Okay, use the latest value of xi when you start proceed. Okay, don't forget that. Okay, with that we have done the Gauss Seidel. All the best to you. Next week I think you begin your second assignment and third assignment and continue. Okay, with that we stop the lesson here. All the best to you. Thank you very much.